Hello students, in this video we are going to discuss MCQ from practical number 2, that is degree sequence and discuss stress algorithm. So first objective is which of the following is a correct statement. First statement is isomorphic graph have same degree sequence. Second, non-isomorphic graphs have different degree sequence. Two graphs are isomorphic if and only if they have same degree sequence, and two isomorphic graphs need not have same degree sequence. Okay, so I am drawing two graphs here. This graph is G1 and this graph is G2. So this is G1 and G2. These are degrees of vertices in graph G1 and these are degrees of vertices in graph G2. 1, 2, 2, 3, 1, 1, 1, 2, 2, 3, 1, 1. So if you observe graphs G1 and G2, they both have same degree sequence, that is 3, 2, 2, 1, 1, 1. Degree sequence of both graphs is 3, 2, 2, 1, 1, 1. But degree 3 vertex in graph G1 is adjacent to two pendant vertices and degree 3 vertex in graph G2 is adjacent to only one pendant vertex. Therefore, G1 and G2 are not isomorphic graphs, but they have same degree sequence. So non-isomorphic graphs have different degree sequence. This is incorrect option because we have found two graphs which are not isomorphic but with same degree sequence. Two graphs are isomorphic if and only if they have same degree sequence. So G1 and G2 both are graphs with same degree sequence but they are not isomorphic. So option C is also incorrect. C is incorrect, and two isomorphic graphs need not have same degree sequence. This is incorrect by definition of isomorphic graphs. If two graphs are isomorphic, then they must have same degree sequence. So first option is correct option. Second MCQ is, let G be a graph on 8 vertices that has no pair of adjacent edges. Then the degree sequence of G is. So let us draw a graph on 8 vertices that has no pair of adjacent edges. That means there is no vertex of degree 2. Two edges are adjacent if, by definition of adjacent edges, two edges are adjacent if there is a common vertex between those two edges. So here E1 and E2 are adjacent edges because they have common vertex V. But we have given G is a graph with no common vertex. That means every edge has degree, no two edges are adjacent. So let us draw a graph on 8 vertices and no two edges are adjacent. So this is a vertex where no two edges are adjacent, or by definition of adjacent edges you can say there is no vertex of degree 2. So E1, E2, V1. So in this graph 2 we can see 2. So this option is incorrect. In first option there are 4 times 2, that means there can be 4 vertices of degree 2. So this option A is also incorrect, and such graph does not exist. We have drawn this graph G with all condition, that is on 8 vertices and no pair of adjacent edges. So option D is also incorrect and option B is correct option. Third objective is, which one of the following sequence is graphic? Actually it is graphical. So by handshaking lemma we know that if there is a graph on p vertices, then summation of degrees of all vertices in graph G is 2 into number of edges. By handshaking lemma, if GPQ is a graph, for graph GP comma Q, summation degree of Vi, I running from 1 to P is equal to 2 into Q. So if any graph exists, then sum of all the degrees of vertices is even number. So let us sum the terms in the given sequences. This is 2 plus 3, 5, 8 plus 3, 11, 14, 17 plus 4, 21, 26. So first option can be correct. So there can be a degree sequence with sequence given in option 1. There can be a graph with degree sequence given in option 1. Similarly, for B, sum is 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 4, 15 plus 7, 22. Sum is even. So there can be a graph with degree sequence given in B. Option B. 1, 2, 3, 4, 5, 6. If you add 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 5, 15 plus 6, 21, which is not an even number. There cannot exist a graph with degree sequence 1, 2, 3, 4, 5, 6. And for last option 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 3, 14 plus 3, 17 plus 4, 21, which is also an odd number. So there cannot be a graph with degree sequence given in option D. So now we have to decide whether option A is correct or option B is correct. If you consider option B, the sequence is 2, 3, 3, 3, 4, 7. So if graph exists with this degree sequence, then P is equal to, no, that is number of vertices in graph G, 1, 2, 3, 4, 5, 6, and a vertex with degree 7. We cannot draw a simple graph on 6 vertices where a vertex with degree 7 exists. So option B is also incorrect and option A is correct option. Fourth is adjacency matrix of simple graph G is. So we have given 4 options where binary and adjacency matrix is binary and symmetric, only symmetric, and none of this. By properties of adjacency matrix, we know that adjacency matrix is binary and symmetric. Option A is correct option. Next is, if G is a simple PQ graph with adjacency matrix A of G, then which of the following is not true? So we will find not true statement. First is A of G is of order P cross Q. This is incorrect statement because A of G is always symmetric. So it has the same number of rows and columns. A of G is always symmetric. So it has order P by P. Number P is number of vertices. So option A is incorrect option. In A of G, every row sum is 2. This is correct statement. A of G is symmetric. This is also correct. Sum of all entries in A of G is 2Q. This is also correct statement. They have asked to find not true statement. So first statement is not true. Option A is correct option. 6. Let M of G be incidence matrix of simple PQ graph. Which of the following statement is not true? Again, we want to find not true statement, but for matrix M of G, that is adjacency matrix of graph G. In our classroom, we have discussed properties of adjacency matrix. That is, adjacency matrix has order P by Q. P is number of vertices, Q is number of edges. Every row sum is 2. This is also correct. Every column sum is 2. This is also correct. Sum of all entries in M of G is 2Q. Correct option is 2Q, but they have given is Q. So option D is incorrect option. 7. The number of graphs with 3, 3, 2, 1, 1, 1 as a degree sequence. Just we have discussed, if there is a graph on P vertices, then sum of degrees of all vertices in graph G must be an even number. So if graph exists with this degree sequence, then the sum of all these terms should be an even number. So let us sum all the terms. 3 plus 3, 2 plus 1 plus 1 plus 1. The sum is 3 plus 3, 6, 8, 9, 10, 11, which is an odd number. So we cannot draw a graph with given sequence. That means there exists zero graph with given degree sequence. Value x if the degree sequence 8x 766 5433111 is graphical. Okay. Again we are going to apply same principle. Sum of all the terms in given sequence must be an even number. So 8 plus x plus 7 plus 6, 6, 5, 4, 3, 3, 1, 1, 1 is equal to 8 plus 7 15 plus 12 27 32 36 36 42 plus 3 45 plus x. So 45 plus x is even if x is odd. So if x is 8, then this is an odd number. So 8, they have given 8 or 7, but it is not true for 8. Similarly, not B is incorrect option and C is correct option. X is equal to 7. So, but if x is equal to 7, x is equal to 7 can be correct option. But if x is equal to 7, then degree sequence is 8, 7, 7, 6, 6, 5, 4, 3, 3, 1, 1, 1. Now I am counting odd terms. How many odd terms are there? 1, 2, 3, 4, 5, 6, 7, 8. In any graph, number of odd vertices should be even. So there can be a graph with this degree sequence. Now again, this if there is a graph with this degree sequence, then the graph has vertices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 vertices. Okay. So it has 12 vertices. I am further checking if x is equal to 7, but after substituting x is equal to 7, I am checking whether this sequence is graphical or not. If x is equal to say we will apply Hakimi algorithm to find whether the sequence is graphical. So if x is equal to 7, then S is degree sequence is 8, 7, 7, 6, 6, 5, 4, 3, 3, 1, 1, 1. So by applying Hakimi algorithm, the new sequence S1 is 1, 2, 3, 4, 5, 6, 7, 8. 6, 6, 5, 5, 4, 3, 2, 2, 1, 1, 1. Again applying Hakimi algorithm 1, 2, 3, 4, 5, 6. 5, 4, 4, 3, 2, 1, 2, 1, 1, 1. That is S2 is 5, 4, 4, 3, 2, 2, 3, 2, 2, 1, 1, 1, 1. Again I am applying Hakimi algorithm to S2. 1, 2, 3, 4, 5. So this is 3, 3, 2, 1, 1, 1, 1, 1, 1. So let us check whether can I draw. No, I am again applying Havel-Akimi algorithm to S3, 1, 2, 3. So 2, 1, 0, 1, 1, 1, 1, 1. So S4 is 2, 1, 2, 3, 4, 5, 6, 7, 0. 1, 2, 3, 4, 5, 6. Okay. 1 is appearing 6 times. So I am cancelling 1 here. 1, 2, 3, 4, 5, 6 and 0. So there is a graph on. So let us draw a graph on 1, 2, 3, 4, 5, 6, 7, 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8, where there is a vertex of degree 0. So I am drawing a graph 1, 2, 3, 4, 5, 6, 7, 8 with 1, 2, 3, 4, 5, 6, 6 vertices of degree 1. 1, 2, 3, 4, 5, 6, one vertex of degree 2 and one vertex of degree 0. So S4 is graphical by Havel-Akimi algorithm. S4 is graphical means S3 is graphical. S3 graphical means S2 graphical. S2 graphical means S1 graphical. S1 graphical means S graphical. So for x is equal to 7, we can draw a graph. So option C is a correct option. Now next MCQ is, which of the following is true about degree sequence 1, 2, 3, 4, 5? Let us check whether the sum of 1, 2, 3, 4, 5 is even or odd. So what is sum of 1, 2, 3, 4, 5? 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5 is equal to 15. So sum 15 is not an even number. This is odd number. So this sequence is not graphical. So first, the sequence is not graphic is a correct option. Next is, if D1 greater than or equal to D2 and so on, DP is a degree sequence of graph G on P vertices, then P1, P minus 1 minus D1, P minus 1 minus D2 and so on. P minus 1 minus DP is a degree sequence of KP. KP means complete graph on P vertices. Complete graph has a degree, every vertex in complete graph has degree P minus 1. So KP has a degree sequence P minus 1, P minus 1 and so on. P minus 1. How many times? P times. So first option is incorrect option. So if you consider a vertex Vi in graph G, then degree of Vi is equal to Di. They have given that degree sequence D1, D2 and so on dp. So I am assuming degree of V1 is D1, degree of V2 is D2 and so on, degree of Vp is dp. And here degree of Vi is, in this degree of Vi is P minus 1 minus Di. So if I add Di plus P minus 1 minus Di, I will get Di minus Di will get cancelled, P minus 1. This is possible only when graph, this is degree sequence of G complement. Why? Because degree of vertex V in G plus degree of vertex V in G complement is always P minus 1. And here we are getting degree of Vi in graph G and degree of Vi in this graph is P minus 1. In the graph with degree sequence this, P minus 1 minus D1 and so on P minus 1 minus D3. It's P minus 1. So this is possible if and only if this is degree sequence of graph G complement. So option B is correct option. Next MCQ is, if A of G is adjacency matrix of graph G, then ones in each row or column denotes. So while discussing properties of adjacency matrix, we have already discussed that number of ones in each row or column of adjacency matrix denotes degree of corresponding vertex. So option B is correct option. Next is, if M is incidence matrix of graph G, then every column sum is 2. Already we have discussed this in our classroom. Next, we have given a matrix and we will solve objective number 13, 14 and 15 by using this matrix. So this is an adjacency matrix of graph G, that is A of G. So if vertices in graph G are V1, V2, V3, V4, V5, V4, 5, then we know that row sum or column sum represent degree of corresponding vertex. So V1 is row R1 is corresponding to vertex V1. So if I sum elements in R1 which are 0 plus 1 plus 1 plus 2 plus 0, that is 4, then 4 represent degree of vertex V1. So degree of V1 is 4. Similarly, this is row 2 corresponding to vertex V2. So if I sum all the elements in R2, the sum will represent degree of V2. So degree of V2 is equal to 1 plus 0 plus 0 plus 0 plus 1, that is 2. Likewise, we can calculate degrees of V3, V4 and V5. Degree of V3 is 1 plus 0 plus 0 plus 1 plus 1, that is 3. Degree of V4 is equal to 2 plus 1, 3, and degree of V5 is equal to 2. So degree sequence of graph is, if I write degrees in ascending order, then degree sequence of G is 2, 2, 3, 3, 4. So 13th MCQ is, the degree sequence of G is, already we have found degree sequence is 2, 2, 3, 3, 4, which is given in option A. So option A is correct option. 14th MCQ is, the size of graph G is. Let us recall what is size. Size means number of edges in graph G. Number of edges. Size means number of edges. So by handshaking lemma, we know that summation by handshaking lemma, sum of degrees of all vertices in graph G is 2 into number of edges, that is summation degree of Vi, I running from 1 to P, is equal to 2 into number of edges, that is 2 into Q. We want to find Q, that is number of edges. What is sum of all vertices? 2 plus 2 plus 3 plus 3 plus 4 is equal to 2Q. 2 plus 2, 4 plus 6, 8. 4 plus 6, 10 plus 4, 14. 14 is equal to 2Q. That means Q is equal to 7. So size of graph G is 7, which is given in option B. Option B is correct option. The entry at position 4, 2 in the matrix A square is. We want to find entry in A square. We have given A. So 4, 2. 4th row, second column in A square. So I will multiply only 4th row of A and second column of A. So what is 4th row? 4th row is Fourth row, this is fourth row. 20100. Fourth row is 20100 and second column. What is second column? 20100. Second column is 10001. 10001. So what is multiplication? 2 into 1, 2 plus 0 plus 0 plus 0 plus 0 is equal to 2. So four-tooth entry of a square is nothing but 2. 2 is given in option A. So option A is correct option. So we have discussed all MCQs of practical number 2. In our next video, we are going to solve MCQs of practical number 3. Thank you.